Welcome back to Talk Tensors, the show that takes you on a journey through the most fascinating machine learning papers. Today we're diving into a preprint that's really caught our eye.
Oh yeah, this one's a good one.
It imagines a future where AI is not just a tool, but an active partner in the design process.
Exactly. It's called From Idea to CAD, a language model-driven multi-agent system for collaborative design.
Catchy title. So is this about simplifying CAD software, or is there something deeper going on here?
Well, it definitely touches on accessibility, but it's really about changing how we think about design itself. You know, the researchers envision a world where AI isn't just helping designers, but actually participating as a creative partner. They've created a system where different AI agents, all powered by vision language models or VLMs, work together kind of like a human design team.
VLMs, those are like a step beyond those large language models we see in chatbots, right?
Yeah.
Like GPT and Llama and all those.
That's right. LLMs are amazing at understanding and generating human language. But VLMs take it further, integrating image processing too. So they can analyze a sketch, interpret a design brief, even provide feedback on the 3D model as it's being created.
So it's like giving AI the ability not just to read, but also to see and interpret our creative ideas.
Mm-hmm.
How do the researchers organize these VLMs to function as a team? Was it just a random collection of these things, or do they have some sort of structure?
They took a cue from human design teams and established 3 primary agents: the requirements engineer, the CAD engineer, and the quality assurance engineer.
Those are some interesting names. Do they actually function like their human counterparts?
They really do. The requirements engineer is like the communicator clarifying the design specs with the user, just like a human engineer would gather requirements. The CAD engineer is the builder using something called the CAD query library to generate the actual CAD code based on those specs. And the quality assurance engineer acts as the inspector, analyzing the 3D model and giving suggestions to the CAD engineer for improvements.
It's like they've created a mini AI design firm. And what I find really clever is how they structured this system. They actually modeled it after the classic V model from engineering. You know, we start with high-level requirements, move down to detailed specs, then we build and then test and verify rigorously.
Right. The V model is like the tried and true method for complex engineering projects.
Exactly. And by mirroring this proven framework, they've given their AI system a really structured way to handle the intricacies of the design process. Now, to really grasp this research's potential, let's zoom out a bit. You know, Talk Tensor is all about connecting the dots between research and the broader trends in ML. So how did we get to this point? Where did this all begin?
Well, we've seen a really fascinating evolution in CAD software and its relationship with AI. Early CAD systems were incredibly complex, required specialized expertise, and you could spend hours and hours working on even simple designs. Then we got more user-friendly versions, with intuitive graphical interfaces, but they still demanded a certain level of technical skill. And AI had been making inroads into the design world for a while, mostly as assistive tools, helping out behind the scenes.
Right. I remember seeing AI used for things like generating design variations, optimizing structures for strength, or even predicting how a design might perform in the real world.
Right.
But it was always more of a supporting role.
Exactly. More in the background.
So what was the turning point? What brought AI to the front of the design stage?
I'd say it was the emergence of large language models and then subsequently vision language models. With LLMs, we could finally communicate with computers in natural language. And then VLMs bridged the gap even further, allowing computers to process and understand visual information like sketches and diagrams. This ability to see and interpret our ideas was crucial for developing this kind of multi-agent system where AI actively participates in the design process.
Right. It's like we finally taught computers to speak our language, both literally and visually. So we've got this team of AI agents structured like a human design firm, powered by VLMs that can see and interpret our ideas, all working within a proven engineering framework. That's pretty groundbreaking stuff.
Yeah.
But what are the real world implications here? What does this mean for, say, the average person who wants to design something?
The potential is huge. Imagine a world where anyone, small businesses, hobbyists, students, anyone could design and create with the help of this AI team. You wouldn't need years of training or expensive software. You could just have an idea and bring it to life with the help of AI.
That's a really fascinating point. We often focus on the technical achievements in AI research, but the accessibility factor is crucial for wider adoption and impact. But even with this user-friendly approach, I imagine there are still challenges. What were some of the hurdles the researchers encountered? Did they hit any roadblocks?
They did. They found that the AI system excels at handling relatively straightforward designs, things like basic shapes and simple structures. But when faced with more intricate designs, especially those involving complex spatial relationships and orientations, it struggles.
It's like the AI can understand the individual pieces, but has trouble figuring out how they fit together in a three-dimensional space. So while the potential is huge, we're still in the early stages. It's like the AI can understand the individual pieces, but has trouble figuring out how they fit together in a three-dimensional space. So while the potential is huge, we're still in the early stages.
Now, before we shift gears to our novel notions segment, where we'll dream up some exciting research possibilities inspired by this paper, I'm curious about something. Did the researchers test this AI system in real-world scenarios, actually have it design something tangible?
They did. They fed the system a range of design inputs from simple hand-drawn sketches to photos of real-world objects.
Yeah.
Things like a basic rectangular block, a block with holes, a rudimentary sketch of a toy car, even photos of a plastic cap and an angle bracket. A good mix of basic shapes and more intricate designs. And what were the results? How did the AI handle these real-world design challenges?
Well, it was pretty impressive, especially when compared to using just a single VLM without the collaborative agent structure. The multi-agent system consistently produced designs that were more aligned with the specifications and required fewer revisions.
I see. So the collaborative approach, much like in human design teams, seems to be key here. The whole is greater than the sum of its parts.
Exactly. And to confirm this, they did what are called ablation studies, where they remove individual agents to see how it impacts performance.
Oh, so they might take out the quality assurance engineer to see if the CAD engineer could still generate effective designs on its own, kind of like seeing what happens when you take a key player off the team.
Exactly. And the results really underscored the importance of each agent. The requirements engineer was vital for clarifying the design brief. The CAD engineer was obviously needed to produce the code. And the quality assurance engineer significantly enhanced the accuracy and overall quality of the final design.
This really highlights that teamwork, even in an AI context, leads to better outcomes. It's fascinating how they've mirrored human design processes in their system. But you mentioned earlier that the AI struggled with more complex spatial reasoning. What are some of the reasons for this limitation? Why is spatial reasoning such a hurdle for AI?
Well, it partly stems from the inherent challenges of representing and manipulating three-dimensional relationships in the data that VLMs are trained on. It's one thing to train a model to recognize objects or generate text, but it's an entirely different challenge to teach it to grasp spatial relationships and manipulate those in a 3D environment. Think about it. We humans take our spatial reasoning abilities for granted, but they're incredibly complex.
That's a great point. There's still a gap between human intuition and AI's current capabilities in spatial understanding. It's clear that this research is just the beginning. There's so much more to explore and refine. And speaking of exploration, I think it's time for our favorite segment, Novel Notions. Ready to put on our speculative thinking caps and imagine some exciting research directions inspired by this paper?
Always. This paper has certainly sparked some ideas.
Well, one thought that came to mind is what if we could train these VLMs on a vast data set of successful designs from diverse fields like architecture, fashion, product design? Could we create AI agents that not only generate CAD models, but also propose innovative, aesthetically pleasing, and functional designs?
You're essentially talking about developing what we could call evolving AI designers. Imagine feeding the VLM a massive collection of designs. Award-winning architecture, commercially successful products, ingenious engineering solutions. The AI could potentially learn the underlying principles of good design, aesthetics, functionality, efficiency, and then apply these to suggest novel solutions.
That's an incredible concept. It's almost like having an AI brainstorming partner that's constantly pushing the boundaries of creativity. It could spot patterns and connections that humans might miss, leading to genuinely groundbreaking design solutions.
Exactly. And this evolving AI designer could also be used to refine existing designs. Imagine taking a product and asking the AI to suggest improvements. Better ergonomics, enhanced aesthetics, or even ways to make it more environmentally friendly. The possibilities are quite vast.
This brings up another intriguing notion. What if we take this concept of collaborative AI design and bring it into a virtual world? We could call it the design metaverse.
I like where you're going with this. Picture this. You put on a VR headset and step into a virtual design studio. There you meet your team of evolving AI designers. Imagine sketching a rough concept for, say, a new gadget using virtual hand gestures, and the AI instantly transforms your scribbles into a refined 3D model.
And we could have multiple users, designers, and engineers from around the world all collaborating in this virtual space, refining the design together. It would be a game changer for remote teamwork.
Think of the educational possibilities as well. Students could learn design principles in an immersive, hands-on environment, receiving instant feedback from their AI mentors. It would be like having a personalized design tutor available around the clock.
These novel notions are really exciting. The idea of evolving AI designers and a design metaverse paint a compelling picture of the future of design. But before we get too carried away, let's bring it back to the research paper we're examining. Did the researchers delve into how they specifically trained and evaluated these AI agents? You know, the nitty-gritty details, the machine learning side of things.
They did, and it's worth taking a look at their methodology. They trained their VLMs on a data set specifically designed for CAD-related tasks. This data set included pairs of sketches and corresponding CAD models, which allowed the AI to learn the relationships between visual representations and the underlying code.
So it's like teaching the AI to read blueprints and understand how they translate into a three-dimensional object. Makes sense. How do they measure the system's performance, though? Did they just eyeball it, or were there some specific metrics they used?
They used a combination of quantitative metrics and qualitative assessments. On the quantitative side, they looked at things like the accuracy of the generated CAD models compared to the original specifications. They also considered the number of revisions needed and the computational efficiency of the system.
Right, so they wanted to make sure the AI was not only accurate, but also fast and efficient, which is crucial for a practical design tool.
Yeah.
What about the qualitative assessments? How do you measure something as subjective as good design?
That's where human judgment came in. They had expert designers evaluate the AI-generated models looking at factors like aesthetics, functionality, and how well the design met the original requirements.
So it was a blend of objective metrics and the discerning eye of human experts. Always good to have that human touch, especially when it comes to something like design. Did the researchers discuss any plans for future research? You know, the directions they want to explore based on these findings?
They did. They acknowledged the limitations of the current system, particularly its struggles with complex spatial reasoning. One area they're keen on exploring is incorporating more advanced 3D representations into the training data, which could potentially improve the AI's ability to grasp spatial relationships.
It's like giving the AI a deeper understanding of the three-dimensional world, moving beyond simple shapes and into more intricate structures. What other avenues are they planning to investigate? Anything else on their research roadmap?
Another fascinating direction is exploring the integration of user feedback into the design process. Right now, the AI mostly works from the initial specifications, but what if it could learn from the user's ongoing input, adapting and refining the design in real time based on feedback?
That would be incredible. Imagine sketching an idea, seeing the AI's interpretation, and then being able to say, actually makes this part a bit curvier, and the AI instantly adjusts the model. It would be a truly interactive and collaborative design experience. Well, we've covered a lot of ground today, from the fundamental concepts of VLMs and multi-agent systems to the intriguing possibilities of evolving AI designers and a design metaverse. This paper has given us a lot to ponder. Any final thoughts before we wrap up this deep dive?
I think this research is a powerful reminder that AI isn't just about automating tasks, but also about augmenting human capabilities. This collaborative approach to design, where AI acts as a creative partner, has the potential to unlock a whole new realm of innovation. We're just scratching the surface of what's possible.
I couldn't agree more. It's an exciting time to be following the evolution of AI and its impact on creative fields like design. For our listeners who are eager to delve deeper into the technical details of this research, we've provided a link to the full paper in the show notes. Be sure to check it out, and as always, we encourage you to keep exploring, keep questioning, and keep pushing the boundaries of what's possible with AI. Until next time, keep those curious minds engaged.